Hello friends, we are starting a new chapter over here. It is a moving load and influence line diagram. First of all, we have to know about the moving load. Moving load is nothing but current live load. Example, which is acting on a bridges, gantry girder, roadway. These loads are nothing but the moving load, which make the a special class by virtue of the fact that functions such as bending moment, shear force, deflection, etc. at any point in them vary with varying position of moving loads. It means if the load is acting from one point to the another point, with respect to such a functions will be also changed, like bending moment is also changed, shear force is also changed, and deflection is also changed with the varying of that position and that moving loads. Moving loads often have the dynamic effect of causing impact and vibration in the structures. Since all structure need to design for maximum stresses produced by their load systems, structures subjected to moving loads involve the calculation of the maximum values of one or more. In such, it means if the load is acting on a structure, by moving load acting on a structure at a various position according to their load, various position, the maximum values will be occur. That is, the maximum shear force will be occur, maximum bending moment will be occur at any point. Also, the maximum bending moment, shear force, deflection acting on a various point at various section of the above functions such as shear force, deflection, bending moment, etc. Now, as well as the determination of location of the load system required to produce them. Now, this problem is greatly simplified if curve can be drawn. If we know that at a various position what is the actual load occur on that structure, the curve will be drawn to show the variation in relevant functions, which means at the 0 point and at the 0.5 point what is the actual difference or variation in that function we can find out by using a curve at chosen section of the structure for various position of the load. It means is known as a influence line diagram. That is, if this curve is drawn from a moving unit point load, the functional value for any other system of load may be easily obtained by using principle of a superposition. Such curve called as a influence line diagram. That is, we know the short form is a ILD. The another definition will be an influence line for a function. Example, bending moment, shear force, reaction, deflection, etc. in a structure is a curve which shown its variation at a particular section of the structure for various position of a moving a unit point load. Okay, it's called as the influence line diagram. There has a some sign convention criteria to find out the actual variation in that structure, and some categories, load categories for to determination of a various structure and various variations to find out them. The first one is to find out the actual sign conventions which is occurred in a structure to resolve them. First one is a shear force, second one is a bending moment. These two forces are very important to find out the variation in that structure. For that, we know the actual sign convention in that. First one is a shear force. When the force is negative, when we take force is negative, this is a section line. This is a section line. If this section line act before or after the load, then what is the direction of that force? If direction of that force is vertically upward, then we have taken is the negative sign. If load is acting on behind this section line which is acting in a downward, then we are taking is a negative sign. Same way, if this section line load is acting vertically upward direction, then we are taking a positive sign, or vice versa. Same way, if bending moment we are taken in the structure, if this section line force will be acting a clockwise direction, then we are taking a negative sign, and if the force is apply or act anti-clockwise direction, then we take it is a positive sign. Okay, now there are 5 categories of a load. To find out the influence line diagram or moving load method, first one is a single concentrated load. Here it is a simply supported beam, whether it is a fixed support, whether it is a overhanging support. If here it is a simply supported beam and here it is a single concentrated load acting over here. Moving load means if this load which is acting on here, acting on here positions, then what will be the change in their shear force and bending moment diagram? We have to find out it by using a curve. Second one is a UDL longer than the span. If there is a span having length L, here it is a section line, the length is L but UDL length is A, then here it is a longer than the span. It means UDL which is acting on a over or becoming a span. It means what is the example of that category? It is a railway. If railway start from this point to this point, but train which is acting on or train passing from this rail, then starting point over here and ending point over here, the length of this train is more than that track, it means a UDL longer than the span. Next one is a UDL shorter than the span, which is look like this. So fourth one is a two wheel axial load separated by a fixed distance. This is a wheel load which is separated by a fixed distance acting on a structure. Then what will be a shear force and bending moment changes in that structure? We have to find out by using a ILD method. This kind of a load example is a motor vehicle load. The two wheels are separated by a fixed distance and passing through from that span which is fixed. Now last one is a multiple wheel axial load which is acting on the structure. These are the 5 categories and these are the sign conventions to determine the ILD in that section. Now we are going through a first load category, that is the single concentrated load which is acting on that structure.